Theory meets practice. Harnessing AI for practical implementations in digital archiving. I have the privilege to announce that this is exactly the moment when theory meets practice. The presentations before were more about theory or theory-driven, theory-focused. And now we turn to harnessing AI for practical implementations with more practical focused presentations. I'm István Alföldi. I work for Polyphone, a Hungarian software development and consulting company, and we've been engaged in different digital archiving related projects. The first speaker will be Anssi Jääskeläinen. Anssi is a true technical all-rounder from the South Finland University of Applied Sciences, currently working as a research manager at the Digitalia Research Center. Please, Anssi, the floor is yours.
Okay, so the correct name for the university is Southeastern Finland University of Applied Sciences, but everything you will need to remember is that XAMK. With that you can find it from the internet. And the second most important thing is this Digitalia Research Center that I'm representing. And today we have been hearing quite a lot about LLMs, datasets. Well, Gradio wasn't mentioned, but the demo created by Gabor was created with that, and we have also been using that. But let me take one step back, and I will just start my stopwatch so I will be in time. Now. Okay, so I'm Anssi Jääskeläinen, and from this university, and I work there as a research manager. And well, I also do real work in spite of writing these projects and being in these seminars. I do Python programming, C# programming, a bit of Java and so on. So quite practical things that we have been doing. And this presentation, it doesn't go into details on any of these areas that we have already heard, but instead this is more like a plate of everything that we have been doing during the last 3 years at our university. So a demonstration of things that we have been doing. But let's move on. I assume I have 20 minutes and then 5 minutes for the questions, because I won't be here on this panel discussion, so if you have anything to ask me, then ask me during the lunch or right after this presentation. Okay, so these are some of the things that we have been experimenting, and this presentation, yes, this is only 20 minutes, but this will sort of consider all the boxes that are in blue in this section here. But no, I won't be going into details on any of these. And we have been developing also some things from this speech-to-text category. I, for example, took the speech from Finnish War Marshal Mannerheim and then just subtitled it with freely available open source language model. And it did quite a good job until the language was transformed from Finnish to Swedish. Then it totally messed up everything. So apparently it didn't detect the change. But yes, these are the things that I will cover in my presentation. And on previous presentation we had Hungarian text, and now we have Finnish text here, but no worries, we will be using LLM to translate this into English on one part of my presentation. But I will start with OCRing that we already heard, and if you want to hear, or if you were on Tuesday's DLM forum meeting, then you heard me and my colleague Tuomo to speak more about this, or more details about this OCR method that we have been developing. But in this presentation I won't go into details, but I will briefly go through what we have been doing. But this is the picture that I'm going to use as a reference for for most of these slides that I'm showing here. And this is from the Finnish Labour Archives public material, which you can access via that link. Lots of other, well, I don't know, interesting material, but material at least available via this eArchive, which by the way is our daughter company, this dsec.fi. About the image enhancements, Gabor used these neural networks to do image enhancements, but in this workflow we only utilize these sort of a more traditional ways of enhancing images, OpenCV, Python libraries, NumPy, because these images, they are just mathematics if you go into details, then just zeros and ones. So you can also use these numeric libraries such as NumPy to do these image enhancements. And these are some of the results that we got. And we run all of these through an OCR. And well, actually I have to admit that in this case, the original produced the best results from the OCR engine. So these obviously have quite a cute image enhancement technologies embedded into the actual OCR model already. But still, it's worth trying to do some image enhancement, especially if the material is very degraded or fainted or something like that. And during that project, we also created this report from it, which you can find by Googling this OCR quality key to enhance data mining, or if you remember that DOI, then you can also type that one and you can directly access to that document. But I assume that you will get these slides after the meeting, so yes, then you can just click those. But yeah, most of these image enhancement techniques has been created with Python. So there is a Python workflow that takes the original, creates all of these and runs OCR through all of those. This code is not publicly available, but if someone is interested, we are willing to share that code with you. So then you can further develop that one if needed. So the first step, image to text. And yes, this is not a real archivist trying to OCR things. Instead, this image was generated with our Hippo supercomputer, and we have installed Stable Diffusion for that. And if I remember correctly, it was Juggernaut XL, this specific library that was used to create this image. And I assume that you are all somehow familiar with OCR and HDR technologies, so I'm not going to be explaining those. I'm just telling you that there are many of these freely available open source models, engines for doing this OCRing. Tesseract is probably the most used one. We also use that one, and that's on one of my examples also as a bad example of how things shouldn't be done. Then there is the Spero OCR, TR-OCR, Abby Fine Reader. Well, that's not an open source, that's a commercial product, quite good one. So if you have enough budget, then I would recommend buying that one and using that one to do the OCRing. But otherwise, you have plenty of these open source alternatives available. And yes, next few slides have been stolen from our DLN forum presentation, starting from here. So here is the same text that I showed on that first slide, and then there is this original OCR that was probably done by the scanning software that was used when this image was digitized. And there is exactly one correct word on this one. There are 2 Finnish people on the audience, and they can prove that I'm not lying to you. The rest of that is a complete mess, so not much to feed to any AI. Then there is this Tesseract OCR, and there are 2 absolutely correct words. But the rest is still somehow correct, but still quite a mess, so I wouldn't understand what this was about. But then when we changed this paddle OCR, so we retrained it with some Finnish material, annotated material and synthetic material, and this is the result that paddle OCR produced for us from this image. So quite an enchantment. And I actually had time to try the solution that Cover showed, and it produced quite similar results than this one. So quite a decent enhancement for the image, also for the neural network solution. I think the combination would do even better. So first some kind of image enhancement and then the neural network solution. Still plenty of time, good. But the next step in here, because this isn't completely correct, so oh yeah, there are the results. These slides before the LLM fixes that we tried to do for this OCR text. This ELKA here means Finnish Business Records for Finnish Central Archives, or whatever that is in English, I don't ever remember that correct name. Then NAF stands for National Archives of Finland, and yeah, those were the test materials that we were using. So 3 machine-written test sets and 1 handwritten test set. And there are the enhancements that we managed to achieve with this paddle OCR. And that material was 60s, 70s, 80s, basic archival material, so not that degraded as the ones that Gaber showed us. But now, could we possibly use these LLMs to do some enhancement or corrections to these OCR texts? And yes, I know this is a bit scary thing to do because LLMs tend to hallucinate, as we already have heard. But in this case, I tried it with Copilot and Gemini, but there are also open source models for Finnish that could do this, these fixes also. But these are a lot simpler to use, just copy and paste and click the button and it does the rest. So these are basically completely correct. There are few mistakes on the text, but it doesn't affect the result that much. So I would say that yes, in some cases we could use these LLMs to fix badly OCR texts. But if we would start this from the original OCR, then I actually tried it and it's nothing like this in here. And I think this is a good stage to say that in Hugging phase, where we harvest these models, there are at the moment 1.1 million freely available models and 240,000 datasets that you can utilize. So plenty of options to choose from. And now the translations that I promised to you. I tried it with, well, Google Translate, of course, which is the state-of-the-art translator before LLMs. Then I tried it with Copilot, with Gemini, and with this Helsinki NLP model that has specifically created for Finnish to English translations. And here the, well, green, from my opinion, means very good translation, yellow, sort of a good translation, and red, it has completely changed the meaning of the original texts. So if you aim to use these LLMs to do translations or anything else, you should use at least 2 or 3 different models and compare the results to find the best one. That's the hint number 1 for you. Then when we have the text already corrected, then we can of course extract the keywords from it. And here I used this UNIF tool that has been created by the National Library of Finland, and that is freely available to use for anyone. But we have also embedded that into our Archive solution, which you can test via that archive.memorylab.fi address. It does all sort of nice things in addition to extracting these keywords, but you can test those by yourself. And this also has English UI, so you don't have to struggle with Finnish one. But I would say that the English translated keywords are absolutely correct and very nicely describe the content of the text. The original OCR is completely out of the scope. There are words like hawthorn and electric guitar and laboratory technology and growing and so on. So yes, the OCR quality means quite a lot when you try to extract keywords from text. Then we can of course do summarizations and classifications for the texts, and in there we have this public demonstration available. It was created for an English-speaking company which is located nearby Mikkeli region, and you can access it from there. So basically just feed 2 texts and then press submit and it does the rest. It first uses Gaussian similarity function to compare the text, how similar those are to each other, and then there are 4 different openly available large language models behind the UI, which first tries to find the tone of the texts, then they create the summary of the text, and finally they will do the tagging for these texts. So another way of using tagging. And again, my hint to you is use at least 2 or 3 different tagging methods, so then you can pick the cherries from the cake and get the best keywords for your texts. Then we will move to the second step, which is image segmentation, because quite often these texts that are in the archives also contain some kind of images or drawings, and it would be quite beneficial to also know what is in the images, not only the text part. And in this image, which is by the way the Church of Mikkeli, maybe from I don't know what year, 50s, 60s, something like that probably. First I used this Microsoft ResNet 50, and it identified that this picture has church and church building, and the confidence is also given. So that was quite okay. Then I tried another openly available model. Yes, these are all available from Hugging Face. And it identified a clock, and yes, there is a clock on that church tower, so yes, absolutely correct again. And then I used this open model from NVIDIA, and it identified things such as wall and building and sky and tree and earth and painting, signboard and clock. And if you take a look at that picture on a larger scale, then there actually is a signboard in that image. It's quite small behind the bushes, but there is one. So again, quite a good job, but one of these models again should be combined. So collect keywords from various models. Okay, so now we have the text extracted from that previous image. What if we want to know some more about that? That could be, for example, embedded into the UI that you will show your clients. And maybe there could be a button that just says, tell me more about this one. And the texts on the right-hand side are created with Copilot. Yes, that's the one that I used. So I just fed that original text to Copilot and asked it to produce some more information about this. And I did a fact check on this one, so it's almost completely correct, except this part. It says that there was only 5,000 Russian soldiers on that battle, but the correct number is 6,000 according to history books. But otherwise, the information in here is correct. Then visualization, and yes, I know that some of you recognize the building from the lower left-hand corner, and yes, I know it's architecturally important building, but I still tried what stable diffusion and this in-paint feature could do with that. So if you look at it closely, you obviously see that the roof has been changed, and then all these modern things from the image are gone. There is a one on the left-hand corner of that original image. It has been removed. Flags are removed, so I made it a bit more Gothic or a bit more medieval-like castle. So quite a lot of things that you can do with image generators. And now I have a question for you. There was this Kyyhkylä Manor mentioned on the previous slide, which is a true manor nearby Mikkeli. So which one of these images is the real one? Is it left or the right one? No, it's the right one. So stable diffusion can do very remarkable things when prompted correctly. I would say that the most important point that tells that the left one is incorrect are the windows on the roof, because when this manor was built, they didn't have technology to build such roof windows. But this is something that you could do. Well, I'm not an archivist, I'm not a historian, I'm not a linguistic, and reading bare text is just boring. I want to have images. So, which is probably the same thing for most of the archival clients. They want to have some visualization. So if your content doesn't have it, then you could use some kind of stable diffusion or DALL-E or something like that to visualize your content. So it would be a bit more interesting for the clients. But of course you will need to tell them that this image isn't real. It just tries to visualize the content that you have on this text. And actually that was my last slide, and don't worry about the minor text on the bottom. It just gives the prompt that I was using to generate this image with our supercomputer. Thank you.
Thank you, Anssi. So it's time for some questions. So Anssi won't be with us at the panel discussion in the afternoon.
Then you will need to ask something.
Okay, that do you?
I have a question to you, Anssi. You showed us that there were a translation of the text, of the OCR process text. Is there already an institution who started to translate their original content, digitized original content, and provide it to users?
At the moment, I don't know any of such company or archive, but we have already submitted a Central Baltic application which includes National Archives of Finland, National Archives of Estonia, and National Archives of Latvia. And in that project, we have written that I could, for example, use Finnish to search things from the Latvian National Archives, and then I would get the results from that archive translated into Finnish. But that will happen if the project gets funded. And this would utilize these openly available LLMs.
Thank you.